I have that, and I have this, and I have this. Can I make a triangle out of those three segments? I can't. They're not long enough, right? If I break it, but I don't want to break it, pretend it's metal or something and we can't break it. There's a certain rule we have to follow, because sometimes if I give you three side lengths, no matter what you do, they're not going to be able to make a triangle. So here is what we are going to do. We are actually going to jump clear down here. Can segments with lengths 4.3, 5.2, and 6.1 feet form a triangle? So here's what we're going to do. Do you see where I'm working example 4 halfway down your paper there? Looks just like this. Here's what we're going to do. We're going to set this up three different ways. I have 4.3 question mark, 5.2 plus 6.1. And then I'm going to have 5.2 question mark, 4.3 plus 6.1. And what's my third combination? Okay, and let's go in here and let's simplify. I bring down my 4.3, and I want to know what goes in here. Is it less than, greater than, or equal to? 5.2 plus 6.1 is 11.3, and this is less than. It's a smaller, and then it gets larger. I say this is the less than symbol. So then I look at this one, 5.2. I add those two numbers, 10.4. Points towards a smaller number. The larger part is eating the larger number. And here, 6.1, I add these two, 9.85, and it's less than. Does the arrow point the same way for all those? Yeah. So here's what happens. Those two sides are larger than the third for each of these. So I say, yes, the sides form a triangle. Make note of that. I say, yes, the sides form a triangle. So again, if I take these two other sides, and supposing those two other sides were larger than this third one, it would form a triangle. Okay? So that needs to be true. We're going to bounce. We didn't even finish that question, but we're going to bounce back up here. So, given this triangle right here, it says, tell whether the given triangle is a right triangle. I'm telling you right now the side lengths do form a triangle. You see it. But I want to know, is it a right triangle? And with our theorem, our Pythagorean theorem, it says c squared equals a squared plus b squared, right? If it's equal to, it's the right triangle and it all works out. How do I know what my c value is here? How do I know what the longest side is? Do you know what this number is? 3 squared root of 34? Type in 3 square root 34, and John gets 17.49. So I just make a mental note. I'm like, this side is roughly 17.5. That just helps me identify which is the longest side. So I'm like, this is the longest side. So we set up this formula. It's called c squared question mark a squared plus b squared. It's the converse of the Pythagorean theorem. And if you put your c first, you'll understand in a few minutes why I want you to put the c first. So what's my longest side? This one is. I need to prove it is a right triangle, or I need to prove it is not a right triangle. So my c value, this is the longest side, the 17.5. But I'm not going to use the decimal. It only tells me, hey, that's the longest side. So I take my 3 square root of 34, and this whole thing must be in parentheses. If it's not, you're going to get a different answer. That's not going to be right. So here's my c, and then we have our a and our b. Leave your question mark in there yet? 9 squared plus 15 squared. In your calculator, you can do this one of two ways. I already typed this in. I had my answer. And so if you push this 2 without pushing anything else to square it, it's taking my answer, squaring it, and now we get 306. Another way to do it, type in parenthesis, type in 3 square root 34. But here is where it's so important that you watch and pay attention. You need to arrow out arrow out from under the square root, close your parenthesis, and now square it. And you also get 306. Let's keep going with this. So we squared this, we get 306, question mark, 9 squared, 81 plus 225. If they're on the same side, we add them. Are they equal to each other? Yes, so put an equal in the middle. And that's what we've said with Pythagorean theorem. If they're equal to a squared plus b squared equals c squared, then that's a right triangle. So I say, is it a right triangle? Yes, it is a right triangle. Yes, it's a right triangle. How about this one? Let's do it again. I need to know, is this a right triangle? So I use my rule, c squared, question mark, a squared plus b squared. What's my c value have to be? 26, because it's the longest, it's the largest number. 26 squared, question mark, then I have 22 and 14. 676, okay. And 14 squared is 196. It's in the last step here that I figure out, are these equal? What's 44 plus 196? 680 and 676, are those equal? It's not until this step that I know. I'm like, oh, that's not equal. This one's less than 680. So what would be your guess? If it's less than, it's acute. And that's why I said put C first. Because if you put your C first, you get the less than symbol, it's acute. If you put C last, everything's going to be flip-flopped. You'll have the greater than symbol, and it'll turn out being acute, and it just gets confusing. So we say it is not a right triangle. And why is it not a right triangle? Because it's an acute one. How about here? Tell whether the triangle with the given side lengths is a right triangle. I need to know what's 4 square root of 3. So we go to our calculator, we type in 4 square root of 3, we see what's the decimal equivalent. 6.93 if we round it. So this is approximately 6.9. But I don't want to use a 6.9. That just tells me what's my C value, what's the longest one, what's the largest. 8 is. So we say C squared, my largest number, question mark, a squared plus b squared. You never use the decimal in here. Never. Use your square root. 8 squared is 64. 4 squared is 16. And then in your calculator, 4 square root of 3 squared. One more time. Type in parenthesis 4 square root 3. But you have to arrow over. If you don't arrow over, it's going to give you a different answer. Now close your parenthesis and now square it. 48. Very good. I add them together. We get 64. 64 does equal 64. So I say, hey, that's a right triangle. Do the second and the third one. You guys got these? My largest number is 14. So that's my C. A squared plus b squared. If it's less than, it is acute. And then when we do square root of 61, I'm like, well, what's the square root of 61? 7.8. That just tells me, oh, that's the largest side. This has to go in place of my C. So I have square root of 61 in parentheses, and we square it. If you have a square root and a square root, what happens? They cancel. Oh, I do know what that is. $61 does equal 61. So I say It is a right triangle. If the triangle is acute, you need to underline that, you need to highlight it, you need to do something so that you know what you're doing. If it's acute, something happens. And if it's obtuse, something else happens. What is that? If c squared is less than a squared plus b squared, it's acute. And if c squared is greater than a squared plus b squared, then it's obtuse. So we had started with this. We're like, if the arrows go the same way when we just add 3 different ways, then that shows us it's a triangle. We don't have a picture, so I'm like, well, I need to know, do these form a triangle? Yeah, they do. So now my question is this triangle acute, right, or obtuse? So we take our c squared, question mark, a squared, plus b squared, and we see what we get. This right here, I know it looks like it's less than, but this does not tell me anything about the triangle being acute at all. Do you see this? This does not tell me it's acute, because every single time it's a triangle, it's going to be less than. That doesn't mean it's acute. If we go 6.1 squared, 37.21, 4.3 squared, 18.49, and 5.2 squared, 27.04. Same side, so we add. Just by chance, this one is less than, so this one tells me it is acute. And again, that's just by chance. Show segment lengths 3, 4, and 6 can form a triangle. Classify the triangle as acute, right, or obtuse. Do they form a triangle? We can't tell it's acute, right, or obtuse unless you do this first. How do we tell if they form a triangle? What do we do here? Write your 3 different sets, see if the arrow points the same way. So we have 3 question mark, 4 plus 6. We have 4 question mark, 3 plus 6. And what's my other option? This simplifies to 10. That's less than. That's 9. It's less than. It's less than. They do go the same way, so we're okay. Do they form a triangle? Yes. The sides form a triangle. If one of those were different, we'd say, no, they do not form a triangle, and then we're done. So because they do form a triangle, I want to know, well, what kind of triangle is it? What do we do to tell what kind of triangle it is? A squared plus b squared. C squared question mark a squared plus b squared. What's my c? 6, 3 squared, and 4 squared. Simplify it. What kind of triangle is this? Obtuse. It's greater than, it's big, we think it's, oh, so obtuse. Got it? Like acute is small and little with the less than sign. Obtuse is great and big. So it's obtuse.